This is a 1 gigabyte file, and after the compression process, its size became only 500 megabytes. It's the exact same file. I didn't delete anything from it, nor did I change its content. So, how did its size shrink by half? Let's see how the file compression process works. If I have the letter X, or any other letter, repeated 10 times in a file, for example, first of all, the computer doesn't see it the way it appears on the screen. It sees it in a binary format. So simply, the first step of the compression process. I have a single value repeated 10 times. Why should I take all 10 instances and write them out? Let me just take 1 and multiply it by 10, because 1x 10 equals sign 10. And if I added 10 ones together, the result would also be 10. In this way, I've simplified it without deleting anything. And of course, this doesn't just apply to letters. You might have a sentence or a piece of code that is repeated multiple times. This way, you take just one value and multiply it by the number of times it repeats as the first step in the compression process. We will need the second step if there is more than one thing repeated in the file. Again, I'll use letters as an example so the explanation is clear. Initially, I will take each letter only once, meaning I take just one value and multiply it by the number of times it repeats, just like we did at the beginning. After that, I will represent them in bytes and add them up to find out how much storage space I need for them. Since 1 byte equals 8 bits, and let's say their total is 11 bytes, I'll multiply that by 8. So, I will need 88 bits to represent them. And here is where the second step actually comes into play. We will take the letters and arrange them from the most repeated to the least repeated. We assign the smallest possible number of bits to the most repeated ones, and the largest possible number of bits to the least repeated ones. After this process, let's go back and see how much space is needed to store them. The letter A, as we know, is repeated 5 times. I will multiply it by the 1 bit I assigned to it, so the result is 5 bits just for the letter A. As for B, I will do the same thing. B is repeated 3 times, and I assigned 2 bits to each of them, so that will be 6 bits. For C, it's the same. C will be 6 bits because it's repeated twice, and I assigned 3 bits to it. Since it repeats less than B, I give it more bits. As for X, which took the highest possible number of bits because there is only one X, it will be multiplied by 1, so the result is just 4 bits. If I were to add them all together, the result would be 21 bits. So you would have dropped from 88 bits down to 21 bits. This is the simplest way to understand how any file compression process works. But there is just one thing left. Dropping from 88 bits to 21 bits is considered excellent as a ratio. Don't focus on the fact that the actual number is very small. I'm talking about the percentage. Going from 88 bits to 21 means it dropped to less than half. This is an incredibly good ratio. And you won't get this with videos and photos because videos and photos are already compressed files. Meaning, if you tried to compress a video that is 1 gigabyte, after compression, it might become 700 megabytes or so. It won't be compressed by this huge ratio. It won't drop to less than half, because video files are already compressed, as I mentioned. It's like taking a sponge that has already been squeezed and trying to squeeze it a second time. You might get a tiny amount of liquid, or you might get nothing at all and find it completely dry.